Alright, we're talking about Venn diagrams, so hopefully you've seen them in the past. First thing we're talking about is independent, dependent. So we're going to talk about some situations you have to identify. Is this events independent from each other or dependent? So independent just means they do not affect each other. Like if I flip a coin, just because I land on heads the first time doesn't necessarily mean anything else. It doesn't mean that the next one's got to be tails. Dependent is dictated. So for example, if we have, you're going to see on the next page, but if I took something out and I put it aside, that is now being affected. Because now there's less number of whatever in the pile. So flipping a coin and then rolling a dice. So if I flip a coin, just because I land on heads doesn't mean I'm more likely to get an even number. So that's why it's independent. Drawing a card from a deck, setting aside and selecting a new one. So you gotta think for a second. There's 52 cards in a deck. If I select a card, that's a whatever out of 52. The moment I take it out, there's now 51 cards. So that means it is dependent, because if I take out a card, it could affect my probability. Selecting a marble, putting it back, and then selecting another one. So let's say there's 15 marbles. If I take one out, there's now 14. But if I put it back in, that's 15. It's like I'm starting all over again. That's why that one's independent. Rolling a pair of dice. One of them doesn't affect the other one. Selecting a student, go in the hall, and selecting another one. So if I have 20 students in the classroom and I tell one of them to go outside, now there's no 19, which is going to now affect my decision. I'm going to go ahead and skip these because we don't have any. We do this in class. But we're going to do this one. It says, in a class of 40 students, 25 are taking English, 17 are just taking math, 7 are taking both. So we'll get to A and B. We'll answer them in a second. But if you look for a second, if you count, there's 40 total students. If you really quickly on your own take 25 plus 17 plus 7. If I do it on my calculator, 25, I can't do it, 25 plus 17 plus 7. I have 49. That means there's 9 random kids together. So the first thing you can do is put 7 right here. It says that there are 25 people taking English. It does not say how many people are strictly taking English. So there could be some of those people taking math as well. So what you're going to do is take 25 minus 7. Because 7 of those 25 students are taking math. So I took 25 minus 7. I do the same thing, 17 minus 7, and get 10. So that means 10 students are just taking math. If I highlight this, everyone inside that circle is taking math. Well, that's 10 plus 7. Well, that's 17. Same thing over here. If I take 7 plus 18, that's 25. So I'm still following the rules. Now if I take 18 plus 7 plus 10, I get 35, which means I have 5 extra students not taking anything. So how many students are not taking English and at the same time not taking math? That's 5. How many students are in math class only? That's 18. And 10 people are only in math class only. Alright, so here's some terms. The word mutually exclusive, it means they do not share anything. So if we were to do one and it happens, we automatically draw this. This means if it's blank for this one. Or that they wrote them separately. Venn diagram. Complement is everything not in it. So I'm going to tell you that everything in A and complement means everything outside of A. So, probability. So first off, there's 28 people in this. So how many people are just like cats? Well, it's not just 6. These 6 people and these 10 people also like cats. Just the difference is these 10 people like cats and dogs. So there's a total of 16 people who like cats and dogs. Over a total of 28. I'm just going to leave them as fractions, just right like that. Same thing with dogs. We're going to take 8 plus 10. We get 18 over 28. Just make sure of something. So there you go. So I want to talk about a couple of things. So if I want to talk about, actually we'll do that next time. Probability of A. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10. So if I want to know probability of A, so there's 1, 2, 3, 4, 5. 5 inside A. Let's do probability of B. 1, 2, 3, 4, 5. 5. Probability of A union. So that's everything in the circle. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. If I want to do probability of A intersect B, that's how many other people like both. There's only one. Complement. And this is how you do complement. You shade in A, and you count how many people are outside of that circle. 1, 2, 3, 4, 5. 5 just like here. If I want to know probability of cats, and I'll say complement. That means if I were to highlight cats, how many are outside of that circle? Well, there's 8 here and there's 4 here, so that's 12. If you notice for a second, 12 plus 16 equals 28, which is a total number, which makes perfect sense. Same thing with dogs. If I highlighted dogs and I count how many outside of it, there should be 10. So probability of dogs complement means everything not inside of it. So there you go. And if I want to know probability, oh, you already did that, never mind. Alright, there we go.